Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today I am going to start new subject, that is power electronics. So in this lecture I will explain course description on power electronics. So first outlines. So in this I will explain first course overview, power electronics course overview, power electronics subject syllabus, subject code, and next textbooks and reference books for this subject power electronics and prerequisites for this subject. And second one, I will explain evaluation methodology, that means marks distribution. And next, the third one, this power electronics course objectives and course outcomes. Next, program outcomes and program specific outcomes, CO, PO, PSOs. And next here mapping of CO, PO, CO and PO, and next CO and PSO, and course articulation matrix CO and PO mapping. Now here, so first course description. So department is Electrical and Electronics Engineering, course title is Power Electronics, and course code is here AEC16, and program is BTech and semester is 5th semester, and course type is core, that means, and the regulation is IARE UG 20, and credits for this subject is 3 credits, and there is a laboratory, power electronics laboratory. And next here course overview, and the course this course focuses on presenting concepts for conversion, control, monitoring of electrical energy using power semiconductor devices. Power semiconductor devices means SCR, triac, MOSFETs, so like that. Next, methods for analyzing power electronic converters that suitable for AC to DC to AC and DC to DC choppers. DC to AC means inverters, and AC to AC cycloconverters, and AC to DC rectifiers. Electrical energy conversions including regulators are presented. And next, additionally, principles for designing power electronic converters, including their power semiconductors and passive elements, are established. The applications of power electronics in the field of suitable energy technologies, switched mode power supplies, that means SMPS, and uninterruptible power supply, that means UPS, as well as applications of power electronic converters for transmission, distribution, and control in the power system is described. This is regarding overview. Now here syllabus. So here this course is total 5 modules here, 1, 2, 3, 4. So first module is power switching devices, and second module is power control rectifiers, and next third module is choppers, and fourth module is AC voltage controllers and cycloconverters. Next, fifth module is inverters. In the first module, thyristor, that means SCR, MOSFET, IGBT, and this power switching devices, IV characteristics, switching characteristics. Next, firing circuits for thyring. So to turn off, so there is a required firing. So R firing, RC firing, and UJT firing circuits for thyristor, gate driving circuits for MOSFET and IGBT, and there is a series connection and parallel connection for thyristors SCR, series and parallel operation of thyristors, rating of SCR, and protection against dV by dt and di by dt, designing of snubber circuit, protection of SCR, and forced commutation techniques, circuits, that means turn off techniques, and other devices in the thyristor family that are triac, GTO, next diac, next their characteristics and some numerical problems. So this is regarding first module. And in the second module, phase controlled rectifiers. Rectifiers, so means that is AC to DC. So now single phase off wave rectifier, this one, and single phase full wave rectifier in that midpoint and bridge configuration full wave rectifier. So for thyristor rectifier with R load, highly inductive load, and in that there are formulas, the derivation of average value, RMS value, next for voltage and current, effect of freewheeling diode, next effect of source inductance. So this is regarding second module. Next, choppers, that means DC to DC converters. So basic choppers operation, control strategies, and step up, and in that there is a derivation of load voltage and load current with R and RL load, and chopper configuration, power circuit of buck boost and buck boost converters, and next analysis of analysis and waveforms of at a steady state. And next, this is regarding third module, and in the fourth module, AC voltage controller. This is AC to AC. So DC, AC to DC, and DC to DC, fixed DC to variable DC, and AC to AC variable, fixed AC to variable AC. In that single phase AC voltage controller. So now here two SCRs in anti-parallel. This is SCR. So two anti-parallel. So this configuration we will use with R load and RL load, and derivation of RMS load and R load voltage and load current. After that, some numerical problems. So up to this here AC voltage controller. Next, cyclo converters. In this single phase midpoint and bridge type step up and step down operations with R and RL loads. Next, this is module 4, and module 5 indicates inverters. Inverters means single phase rectifiers. So basic operation voltage source inverters, and basic series and parallel inverters, series inverter and parallel inverter, current source inverters, voltage source inverter and current source inverter. In the current source inverter, there is a modified MC and this modified breadboard of bridge rectifier, and operation and waveforms, voltage controlled by pulse width modulation techniques. So PWM technique, and single pulse, multiple pulse, and sinusoidal sign. And there are numerical problems, and three phase bridge inverter in that 180 degrees mode and 120 degrees conduction mode of operation. 180 degrees mode conduction operation and 120 degrees conduction mode operation. This is regarding fifth module. So this is our syllabus. So now this syllabus I am going to discuss in this course. So first here, textbooks for this subject. So the best book for this subject is P.S. Bimra. So that is Power Electronics, Khanna Publishers. So 4th edition 2008. And for problematic, M.H. Rashid, Power Electronics, Circuits, Devices and Applications. That is Pearson Edition India. So 3rd edition 2009. Next, reference books for this subject. So UL Umanan and Power Electronics, Essentials and Applications, while India 3rd edition 2009. So next, another book is Power Electronics, Converters and Applications Design. So that is Mohan and Unland, and that is John Ville and Son, 2nd editions 2007. And next, this other and Fundamentals of Power Electronics, that is Springer Science and Business Media, 2nd edition 2007. So these are the textbooks and reference books for this subject. And next, prerequisites for this subject. So first here, so this subject some study is required. So network analysis. So in the third semester subject, that is subject code is in the BTech subject code is AEC05, and analog electronic subject also is required to study this power electronics subject, that is in the third sem, and AEC C07 for BTech subjects. So these are the prerequisites: network analysis and electronics, analog electronics. Next, evaluation methodology. So first here, total 100 marks here, and 70 marks for semester end examination. So that is 3 hours duration, 70 marks. So 70 marks means each module carries equal marks 14. So 14 into 5, there may be a choice. And next, here next 30 marks is divided into CIE 1 is a continuous internal examination, that is first mid-term, so 10 marks, and continuous internal examination 2, that is mid 2, that is 10 marks, total 1890. And these two exams for 2 hours duration, and AAT 1 and AAT 2 5 marks. So this may be a tech talk, and second one is a concept video. And next, total 10 plus 10 20, and 5 plus 5 10, total 30 marks for CIEA. And next, SCE, total 70 marks, total 30 plus 70, 100 marks. Next, course objectives. Students will try to learn these concepts of power semiconductor devices related to its characteristics, rating, and protection to select these devices for various applications. This is objective number 1, and student will try to learn the fundamental principles and control techniques for power electronics converters for analyzing the AC to DC, that is rectifier, DC to DC, that is chopper, and AC to AC, that is voltage controlled rectifier cycloconverters, and next AC to DC means, that is inverter power conversion circuits. And next, third objective for this power electronics subject, here the application of power electronic converters in the field of battery management system, industrial drive applications, and enhancement of power quality. Next, so after successful completion of this course, students should be able to, so total outcomes, so students should be able to explain the static and dynamic characteristics of power semiconductor used for power conversion in the converter circuits. The Bloom's taxonomy level is understand, and course 2 is summarize the various firing circuits, commutation techniques, commutation techniques, turn-off techniques useful for accurate switching function of SCR. And next, third one is analyzing the performance parameters of AC to DC, that is rectifier converters, under various loading conditions, R load, RL load. So now here this Bloom's taxonomy level is analyzed. Second course outcome 2 is understanding that one. And next, fourth outcome is here identify the switching techniques and control strategies in the switched mode regulator, and perform steady state analysis in the chopper circuit. So that is apply. So Bloom's taxonomy level. And CO5, course outcome 5, demonstrate a single phase AC voltage controller and cyclo converter used for converting fixed AC supply into variable AC output. So that Bloom's taxonomy level is understand. And next, 6, CO6, apply modulation and switching topologies in the inverter for output voltage controller. The Bloom's taxonomy level is output. Here Bloom's taxonomy total, here understanding levels are here 1, 2, 3, and analyzing is 1, and apply are 2. So now here you can see the Bloom's taxonomy level. Understanding is 3, and apply is 2, and analyze is 1, remember is 0. So these are the Bloom's taxonomy. Remember, understand, apply, and analyze. Next, program outcomes. So program outcomes here, first one is engineering knowledge, and second one is problem analysis, and third one is design and development of solutions, and fourth one is continuous investigation of complex problems, and fifth one is modern tool usage, and sixth one is the engineer and society. And next, total 12 program outcomes. Now here seventh one is environment and suitability, sustainability, and next ethics. Next, ninth one is individual and teamwork, and 10th one is communication, and 11th one is project management and finance, and next lifelong learning, that is 12th outcome, program outcome. Next, program specific outcomes here. So three program specific outcomes here: design, develop, fabricate, and commission the electrical system involving the power generation, transmission, distribution, and utilization. And next, focus on the components of electrical drives with its converter topologies for energy conversion, management, and editing in the specific applications of industry, and sustainable rural development. And next, gain the hands-on competency skills in PLC automation. So now process controller, HMI, and other computing tools necessary for entry level position to meet the requirement of employer. Next one, COPO mapping here. So COs and POs, course outcomes and course program outcomes, and program specific outcomes already we discussed in the previous slide. So first one, course outcome here. So first course outcome here, course outcome 1 is mapped with PO1, PO2 here, and next PO6 and PO12 and PSO1. And same way here, course outcome 2 is mapped with PO1, PO2, next PO12 and PSO1. And next PO3 is for PO1, PO2, next PO12, PSO1, PSO2. And next CO4 is for PO1, 2, 4 and 12. And next, for the PSOs, program specific outcomes, PSO1 and PSO2. Next, CO5, this one here, 1, PO1, PO2, PO12 and PSO1, PSO2. And program 6 is for PO1, PO2, PO3 and PO12, PSO1 and PSO2. So mapping of each CO and POs, and each CO with PSOs. These are the PSOs and these are the POs. Next, total count of key competences here. So for this, same mapping is same, but here this is 3 CO PO1 for all, and this one is 3, 3, and this is 5 CO3 and PO2, the total count of key competences. And here this is 6 and this one is 5 and 4. This is 6 and 4. And next, for the PSOs 1 and this one 2, 4, 4, 4, 4 and 4. Next, percentage of key competences here. So that is 100%, 100%, 100%, 100%, 100%, 100%, 100%. Next, here 30%, 30%, 50%, 60%, 50%, 50%. Now here 40%, 54.5%, 20%, here 25%, 50, total 50%. And next, this is completely PSO 50% and 33.3 percentage of key competences. And next, here this one, COs and POs and COs and PSOs on the scale of 0 to 3 only. Now here 0 means so no correlation and 1 means low correlation, and next 2 means medium and 3 means high. So now here 0 for 0 for 0 to 5, and 1 for 5 to 60 moderate, and 3 for 60 and above, that is high. So now here, so CO1 is 3. So this one CO1, 2, 3, 4, 5, 6, and that is for PO1 is 1. And next, if you take the average of this, that value is also 3. And next, CO is 1, CO1 and PO2 is 1, 1. This is 2, 3, 2, 2. So if you take average of this, and this value is 2, count it and average, and this one is 1 and average is 1, and 2, this average is 1, and this is 1, average is 1, and next here this 1, 2, 2, 2, 2, 2, and this value is average is 2, and this is total 2, this average is 2, and this is 1, 1, 1, and this average is 1. So this is course attribution matrix for PO and PSO mapping. I hope this course description of power electronics is clear to you. So syllabus, COs, course outcomes, course objectives, PSOs, and COPO mapping, course articulation matrix, and prerequisites for this subject. After that, reference books and textbooks for this subject. I hope all these things are clear to you. If you still have any doubts, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.